Okay guys, so this is going to be our first video over notes. So this is going to be the introduction to chemistry notes. Matter is anything that takes up space and has mass. There's two main groups of sciences that we're going to be dealing with. Biological science is anything that deals with living things. Biology means the study of living things. Botany is the study of plants. Microbiology is the study of microorganisms. Zoology is the study of animals, and parasitology is the study of parasites. The other realm that we're going to be dealing with is physical science. So this is going to be dealing with natural relationships. Okay, so physics, some of you have taken physics before. It's the study of matter, energy, and the relationship in the universe. That's going to be dealing with Newton's first, second, and third law. It's going to be dealing with kinematics, that sort of thing. Mathematics is the language of science, okay? It's used widely in physics and chemistry. Okay, so chemistry, you're in this class, is a science that deals with the structure and composition of matter that constitutes all living things in their environment, deals with the changes in matter, the mechanisms by which these changes occur, the products formed, and the energy changes encountered. Okay, so that's just a fancy-dancy definition. You don't need to know that for anything. Okay, so there's different types of chemistry. So analytical chemistry is identifying the kinds of matter and the quantity of each substance that compose complex substances. So someone that's an analytical chemist is going to be working in the lab. Okay, so those are the people in the lab at the plant. Okay, organic chemistry is involving carbon compounds. Inorganic chemistry specializes in substances without carbon. Physical chemistry is going to be dealing with like Einstein stuff, Oppenheimer, Heisenberg. Those sort of names come up when we're talking about physical chemistry. I hope you never, ever have to take that class because it's not fun. And biochemistry is the study of chemistry and how it relates to biology. Okay, so the importance of chemistry. Chemistry is important because it's used to make new materials, and we can come up with new ways of making old materials. So let's take this for instance, and one of the examples I like to give when we're talking about this is World War II came along, and tanks and all these cars and supplies need to be made, and they all required rubber. Well, before World War II, they had to get the rubber from rubber plants, rubber trees. Okay, so the chemists got together and they decided that they were going to come up with a way with synthesizing rubber. And so like that plant that's out there in Port Neches, used to be Ameripol Synpol, which is currently ISP Elastomers, was a World War II rubber plant. So they make SBR rubber. So that's one way of making old materials, okay? A new way of making old materials. Chemistry is important to figure out how reactions proceed. That's called a mechanism. To determine, identify, and provide concentrations of substances, and how to find how composition is related to properties. Okay, so none of that's going to be on your test. I'll tell you what you need to know first for your test. Okay, so chemistry has some beginnings, okay? Metallurgy is the study of metals, working with metals. Brewing, liquor and beer. So brewing liquor and beer and the study of alcohol is one of the most studied processes in chemical engineering and in chemistry. So that goes way back. Tanning and dyeing, that's going to be like the Indians skinning the buffalo and using their hide for clothing. Okay. Okay, so other beginnings. You had the Greek philosophers. So Aristotle and Plato said that nature was composed of four basic elements: air, fire, earth, and water. We know that to not be true, but they sat around and they had nothing better to do with their lives, you know, back in that time period. And it's kind of crazy that they came up with, you know, these ideas and it kind of shaped chemistry. Okay, the Chinese are responsible for fireworks and gunpowder. So things like potassium nitrate. Metals, different metals burn with different colors because that's the characteristics of metals. In lab, if we get to do it this semester, with this COVID stuff, we do a lab that is a flame test lab where you can identify the color of the metal by the flame it has. Okay, the color of the flame. So that's kind of cool. Contributions during the Middle Ages. You had people called alchemists that tried to turn everything into gold, which we know isn't true. You can't turn anything into gold. You had a guy named John Betcher who was responsible for something called the phlogiston theory and the theory of combustion. And in order for something to burn, it must contain this gas called phlogiston. I don't know where he got that name from, but that's what he named it. Combustion is just a fancy word for burning, so you need to make sure you know that. John Priestley found that objects burned better in a pure gas, which they later named oxygen. Okay, so Priestley went off of Betcher's theory, and then you get this guy called Antoine Lavoisier. Okay, he experimented with combustion. He disproved the theory of phlogiston. He named John Priestley's gas oxygen, and he helped to develop the metric system. Okay, so we're going to learn about the metric system in a couple lessons, and he's dubbed the father of modern chemistry. Other people we're going to learn about are John Dalton. He proposed the atomic theory. Amadeo Avogadro, he described the behavior of molecules. Sir Edward Franklin described how atoms form molecules. So a molecule is when two or more atoms combine. Haeckel is the father of organic chemistry, so he did a lot of organic chemistry study. Dmitri Mendeleev, arranged the elements in a chart called the periodic table. Okay, and Marie Curie discovered radioactive elements, radium and polonium. She won a Nobel Prize, but died by radiation poisoning. It's kind of ironic. Okay, so this is the first thing you need to know. So I'm going to highlight this. Okay. So the first thing you need to know is the scientific method. So I'd like to add this in there too, because for some reason I didn't. Okay, so when we do the scientific method, it goes state the problem. We're going to gather observations. We're going to form a hypothesis. We're going to perform an experiment, and if the experiment supports our hypothesis, it's going to become a theory. Okay, so I like to describe this as a crime scene investigation. Okay, someone got murdered. A pretty blonde lady, mid-30s, got murdered. So our problem in this case is the lady got murdered. She was murdered. Your observations in this case would be collecting evidence. Okay, we're going to collect DNA. We're going to collect blood splatter. We're going to collect evidence, the gun, that sort of thing. Now, our hypothesis is going to be an educated guess. So a hypothesis is always an educated guess. So our hypothesis is who killed her, okay? And our experiment in this case is going to be the interrogation by the cops. So we're going to question him, and we're going to take the DNA evidence or whatever evidence we have and see if it supports our hypothesis. Did the husband murder his wife? Usually, the typical Lifetime movie scenario. Now, if he did murder his wife, it's going to become a theory, okay? So a scientific theory. So that's just my way of explaining this sort of thing. So that's going to be on your test. I'm going to ask you to outline the scientific method, and I want this, okay? Some other important things that we need to know in this. I'm going to write it out for you. So we need to compare and contrast a scientific law versus theory. Okay, so let's start with a law. Okay, so a scientific law is usually quantitative data. Okay, so the word quantitative data, this is important. Quantitative data deals with numbers. Okay, quantitative data deals with numbers. So it's usually a math equation. Okay, usually a math equation. Always true. And it does not describe why. Okay, if I have a scientific theory, okay, it's usually qualitative. It can never be proven. And describes why things happen. Okay, so this is a test question. Now, so I'm going to ask you in your test to compare and contrast quantitative and qualitative data. So quantitative data deals with numbers, qualitative data deals with words, okay? And then I'm going to ask you to compare and contrast a scientific law and theory, and this is what I want to see. Now, if we're talking about practical examples of a scientific law or a scientific theory, a scientific law, we know from physics that acceleration due to gravity is 9.8 meters per second squared. That Newton's first law is an object in motion stays in motion unless acted upon by an unbalanced force. Second law is F net is equal to mass times acceleration. The third law is for every action there's an equal and opposite reaction force, okay? Now, scientific theory. If we talk about some scientific theories, we can talk about the theory of evolution, okay? That we evolved from some other organism like monkeys, okay? Now, that directly contradicts creationism, you know, that we came from a higher being. Same thing goes with the Big Bang Theory. You know, the universe was created from a huge explosion. Well, the converse of that is going to be that God created the universe. Another one that someone came up with this last semester, I'll never forget this because I laughed pretty hard about that. Did Epstein really kill himself? You know, that's a scientific theory, you know. Do we know if he really killed himself? So that can never be proven. Okay, so those are some examples of scientific laws and scientific theories. Okay, now on to 3 states of matter. You need to know this. Okay, so the 3 states of matter. So I'm going to ask you to compare and contrast a solid, liquid, and a gas. So a solid has a definite shape and definite volume. The particles are tightly compacted. A liquid has a definite volume and it will take the shape of the container. Gas does not have a definite shape nor volume, but it fills the container. So pretty much that's what you need to know about this section. Okay, so we're going to talk about physical properties and chemical properties in this next section. Okay, so a physical property depends on the substance itself. Okay, you have stuff called extensive properties. That depends on the amount of matter you have. So something you can measure like mass, length, and volume. Intensive properties do not depend on the amount of matter, such as density or color. So if I have an ounce of gold or a block of gold, it's still going to have the same density. One word that you need to make sure that you know is malleability, ductility, and conductivity. Okay, so malleability is how something can be hammered into thin sheets. So aluminum can be hammered into thin sheets. Ductility is how easy something can be stretched into thin wires. Okay, that's like copper wires and fiber optic cable. Conductivity deals with conducting heat and electricity. Okay. Now, chemical properties depend on the substance in the presence of another substance. So when it's around two other things. So that's going to be like reactivity, electron configuration, ionization energy. You really don't need to know that because I'm going to ask you about physical and chemical changes. Okay, so a physical change only affects the physical properties, okay? So it's only changing the appearance itself. Okay, so if I cut something in half, if I dissolve it in water to make a solution, if I change the state, okay? So let's talk about phase changes real quick. Okay, so a phase change, let's go from solid to liquid. Liquid to solid, and I'm going to name these, liquid to solid. We'll do liquid to gas. Gas to liquid. I usually wing this, so solid to gas, and gas to solid. Okay, so these are all examples of phase changes. They have names. So a solid to a liquid is going to be melting. A liquid to a solid is going to be freezing. Liquid to a gas is going to be vaporization, or yeah, we'll call it vaporization, or boiling. Gas to a liquid is called condensation. Solid to a gas is called sublimation. And a gas to a solid is going to be called deposition. Okay, so the first few, we pretty much know what they are. Condensation, that's like when sweat collects on your glass after the ice melts. Sublimation is like carbon taking dry ice. So dry ice is solid carbon dioxide, and when whenever it starts melting, it's going to go to a gas, okay? And example of deposition is hail. When hail is formed in the clouds, it's going to skip the middle phase, and it's going to go straight from water vapor to solid ice, okay? So you're going to need to know these for your test. These are all examples of a physical change, okay? So anytime I see one of these keywords, it's going to be a physical change. Chemical changes produce new substances. So anytime I burn something, digesting, fermentation. Fermentation means to rot. Okay, so like beer and wine and all that stuff go through a fermentation process. Anytime I break some sort of bond, that's going to be a chemical change. Rusting or oxidation, that's a fancy word for rusting. And then you can tell, there's a few ways you can tell that a chemical change has occurred. So endothermic means it's going to feel cooler. It's going to absorb energy. Exothermic means it's going to release energy. Okay. A precipitate forms when you mix two liquids together. You'll be able to see what this looks like in lab. Effervescence means that bubbles are formed, like fizzing, like an Alka-Seltzer tablet dissolving in water. Okay. We can look at, and we can see a change in consistency occurs, so it gets oily or thick, or if there's a change in mass. Okay, from here, what we're going to do is we're going to go and go through these examples on the back worksheet of identifying chemical and physical changes. Okay, so color. I'm going to say that could be both, because if I add food coloring to a substance, it changes the color, but doesn't change the color of the substance itself. But say I burn something, it's going to turn brown or black. So that's evidence that a chemical change occurred. So that one can go both ways. Reactivity is usually chemical. Porosity, the word porosity means how well something has holes in it. So that's going to be a physical property because it's got holes in it. Stability depends on what you're talking about. If we're talking about chemical stability, whether something reacts in the presence of another, or if we're talking about the stability of a building, okay? So I would say that's both. Expansion, okay? I'm going to think that expansion is going to be physical. So if I blow up a balloon, it's going to expand, but I'm not changing the balloon itself. Flammability is going to be a chemical property. Odor is going to be a chemical property. Ductility is going to be physical because it can be drawn into thin wires. Solubility is how well something dissolves in another substance. That's going to be a chemical property. So different compounds dissolve in water versus other compounds. Rusting is a chemical change. Digestion of food is a chemical change. The fading of dye in cloth caused by chlorine bleach. So chlorine's a chemical, so this is going to be a chemical change. Growth of a plant by photosynthesis. So photosynthesis is actually a chemical process. We take carbon dioxide plus water and it produces glucose plus oxygen. So that's going to be a chemical change. If we're talking about the physical growth of something, expanding, then if it didn't have the word photosynthesis in there, then I would say that it would be physical. Melting of ice, that's a key word for a phase change, so it's physical. Production of sound by vocal cords, that's going to be a physical change because your vocal cords just vibrate with one another. They're not undergoing any sort of reaction. Combustion of gasoline in an engine, that's going to be a chemical change. Formation of clouds in the air, that's going to be a physical process because it goes evaporation, condensation, precipitation. Okay, making rock candy by evaporating water from a sugar solution. So the key word here is evaporating, so that's going to be a physical change. Burning of coal, that's going to be chemical because I'm burning something. Tearing a piece of paper, that's a physical change. Kicking a football, physical change. Excavating the earth, so the word excavating means to dig up, so that's going to be a physical change. Explosion of TNT, that's going to be a chemical change. Smashing a mirror, that's physical. And boiling water, it's physical. Okay, so I just want to make sure we went through that. If you wanted to stop and before we went over this and try and do them yourself, go for it. And if you have any questions on how I did this or how I concluded some of the stuff, just feel free to reach out. Okay, continuing the notes. Almost done. Okay, so we're going to talk about energy. So energy is the ability to do work. We have two types of energy dealing with mechanical energy: potential energy and kinetic energy. Okay, these are on your test. Okay, so potential energy is the energy of position. Kinetic energy is the energy of motion. We also have heat energy, electrical energy, and nuclear energy. Okay, so nuclear energy is going to be coming from nuclear fission or fusion reactions. Anyways, those aren't really important for what I'm getting for you. So just a brief example for kinetic and potential energy. It's going to tie into our next thing. So say I am at the top of a roller coaster, okay? I go click, 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 and you get to the very top. Right before you start going down, you're going to stop moving, okay, theoretically, in a perfect world. Okay, say I have 100 joules of energy at the top. So this is all potential energy because I'm not moving. At the bottom, all of that energy is converted to kinetic energy. Okay, so at ground level, I'm not above the ground, so I don't have any potential energy. So all that energy at the top is converted to, the potential energy is converted to kinetic energy. Now, what if we're in the middle? Okay, so as I lose height, I'm going to be losing potential energy, be gaining speed, so I'm going to be gaining kinetic energy, okay? And then to where it's all converted to kinetic energy at the bottom. Okay, so this goes with the law of conservation of matter and energy. Okay, so this is super important. Okay, so matter and energy are interchangeable. They're pretty much the same thing. So matter and energy cannot be created nor destroyed. They're merely transformed from one form to another. Okay, so that's a good example of conservation of energy. You need to make sure you know that for your test. Okay, classification of energy. Okay, a mixture. So a mixture is a combination of two or more substances that are not chemically combined. Okay, so homogeneous mixtures are the same throughout. So this is going to be like salt solution, sweet tea, contact solution, that sort of thing. So homo means the same. Heterogeneous mixtures are not the same throughout, okay? So this is going to be like a bowl of Lucky Charms. You have the different marshmallows in there with the cereal. I like to say salad is a good example of a heterogeneous mixture because you got your lettuce, you got your cheese, you got your bacon bits, you got your cucumbers, tomatoes, croutons, whatever you want to put in it. So you can physically see the different particles in it. Milk is actually an example of a heterogeneous mixture because it's called a colloid. So apparently when milk comes out of the cow, it doesn't look like what we see from the store, okay? It's not homogenized, okay? So what we see from the store is homogenized and it looks like it's the same throughout. But when it comes out of the cow, it's actually in different layers whenever it sits, you know, so it's actually considered a heterogeneous mixture. Okay, so this is important. Solutions. Okay, so a solution is made up of a solute and a solvent. The solute is the particles that are being dissolved. The solvent is what does the dissolving. Okay, so you need to know this. You need to know those two. Okay, so in contact solution, saline solution, the salt is the solute and the solvent's going to be the water. In sweet tea, we talk about, you know, a lot in this class. So sweet tea is, you know, you brew your tea, it's going to be hot. You put your sugar in it while it's hot and it dissolves. So the solute is going to be the sugar particles. The solvent's going to be the water. Okay, so you need to know those for your test and for your assignment that you have to do over this. Okay, so a pure substance. A pure substance is a sample of matter that has a definite composition. It can be found in earth as an element or a compound. Okay, so an element is just one type of atom and a compound is composed of two or more elements. Okay, so there are 109 known elements depending on which periodic table you're looking at. There are 92 naturally occurring elements. After 92, those are called synthetic elements, so they're made in the lab. Some examples of some compounds that we're going to learn how to name later. Table salt is sodium chloride, water is H2O, and hydrochloric acid is HCl. Okay. And then we're going to go through this last part, and then we're going to label our periodic table, and then we'll be done. So if you haven't printed out your periodic table, this would be the time that you do so. Sorry. So this would be the time you do that. So characteristics of metals. Metals are always located to the left of the zigzag line. I'll show you what that is in just a second. Metals are shiny. They reflect heat and light. They conduct heat and electricity. And they're ductile and malleable, so they can be hammered into thin sheets and they can be drawn into thin wires. Okay, non-metals are to the right of the zigzag line. They're poor conductors of heat and electricity. They are also insulators. And then there's some special groups we're going to talk about. Halogens are salt formers, and then we have the inert gases, which are not going to react with anything. And then you have something called metalloids. Metalloids are elements that have characteristics of both metals and nonmetals. They touch the zigzag line. Okay, we have groups. So groups or families go this way. And then we have something called a series or periods. Okay, so what I'm going to do now is we're going to label our periodic table, and you're going to be using this throughout the semester. So make sure you print it out. Okay, so we're going to start by drawing our zigzag lines. So let me get a marker real quick. Let me make it thick. Okay. So we're going to start at boron, and we're going to draw a zigzag line, but don't get the numbers like I kind of did there, because you're going to need those numbers. Okay? Okay, so that's going to separate the metals from the nonmetals. Okay, so that's why I talk about the zigzag line. So your metals are going to be to the left of the zigzag line, and your nonmetals are going to be the right of the zigzag line. Okay, so what I'm going to do is I'm going to start by labeling this. I'm going to go Roman numeral 1A, 2A, 3A, 4A, 5A, 6A, this is 7A, sorry, I keep hitting my camera, and then 8A. Okay, so old school periodic tables have those. That tells you the number of valence electrons, that's on your test. So the group number tells you the number of valence electrons that you have in the outermost shell. So valence electrons are your electrons that are in the outermost shell. Okay, now we're going to start by writing our charges. So this is a +1 charge, this is a +2 charge. We'll use this for the next test material. +3. Group 4A really doesn't have charges, but they're going to be plus or minus 4. Nitrogen column is going to be -3, -2, -1, and 0. Okay. So we'll use those charges for next test material. Okay, let me see if I can zoom out a little bit. Okay, so we got that going on. Group 1A. Okay, I'm gonna let me finish doing this real quick, and then I'm gonna go through, and I guess I'll write it on the notes, the groups, because it's not gonna be able to work. Actually, we'll do it over here. Group 1A, those are called the alkali metals. Okay, so this group right here is called the alkali metals. Group 2A is called the alkaline earth metals. Okay, so group 2A is the alkaline earth metals. Now, you see the difference in the spelling and everything. You have to make sure you make that distinction. They're not the same thing. This group right here, group 7A, is called the halogens. And then group 8A, which is right here, these are called the noble gases because they don't react with anything. Noble or inert gases. You have the transition metals. The transition metals are down here. Okay, so anything in these shorter column stuff, Those are going to be your transition metals. Okay, they're called transition metals because a lot of them have multiple charges. Okay, now let's go ahead and do this real quick. Zinc always has a +2 charge, and silver always has a +1 charge. So I'll just write those down real quick so we can use those later in the semester. This column, this row right here is called the lanthanide series. This is called the actinide series. Okay, because of this, they're actually inserted right here and right here. So anyways, we just need to be able to label our periodic table that way. Now, I posted a group of elements. I think there's 70 elements on your chart. Hold on just a second. Let me get it real quick so you know what it looks like. I just had it. Okay, I got it. So you have this list of elements. Now I haven't decided how I'm going to do your first test because a lot of this first test is going to be things that, or how we're going to test during the summer because of this COVID stuff. Are we going to have online classes for everything, including lab, or we're going to have any sort of face-to-face time stuff? So I will know that in the next couple weeks, a little bit better plan. But for right now, you need to memorize these, okay? So the way I would memorize this stuff is I would start with 10, memorize those, and then add another 10. If you want to do flashcards or get like a Quizlet app, that will help, okay? So for your first test, you need to have these memorized, okay? What I did this semester is everything was online for the last half of the semester, and everything was open note, open book, that sort of thing. With this first test, maybe even the second test, I don't know if I'm going to be able to do that because, oh, hey, how hard is it to look at your element sheet to know what the elements are? So I haven't decided what I'm going to do yet. I might have to rewrite my first test, but I'll let you know. So you need to start memorizing these from day one, okay? So that's been the Introduction to Chemistry video, and if you have any questions over it, please feel free to reach out. You have an assignment on Blackboard that's multiple choice, fill in the blank, that sort of thing that goes with it. Shouldn't take you too long. Hopefully you have a good night. Thanks. Bye.